In this lesson, we're going to start talking about angles around the unit circle, and what we want to get to over the next couple of days is we want to be able to um, evaluate the trig functions, sine, cosine, and tangent, for all of our special angles all the way around the unit circle, so all through the 360 degrees or the 2 pi if we're talking about radians. So we have what we're going to say this is a unit circle. It's on the x and y coordinate axis. Its center is at the origin. And no matter where I am on this circle, I can always create a right triangle by dropping a vertical and then connecting the center to the point on the circle. So that's the radius, and since we are in the unit circle, we're going to give that a radius of 1. My x value is down here. My y value would be the vertical, and then I'm going to try to squeeze in a teeny tiny theta right in there. So there's my angle. Let me redraw the triangle a little bit bigger. And again, if I have a coordinate that's xy, that means this distance is x, this distance is y. That's going to be a 1 because we're the unit circle, and this is going to be the angle. So I can create a relationship between trig functions and the x and y coordinate that identifies them. If I was going to set up the cosine of theta, if you look at this diagram, it's going to be x over 1. And the sine of theta is going to be y over 1. And then the tangent is going to be opposite over adjacent, y over x. So this is a way to represent my cosine and sine functions, and we will be using this in the future, but basically your x value is equal to the cosine of the angle, and your y value is going to be equal to the sine of the angle when you are in the unit circle. So we're going to break this lesson up into two parts. The first part is going to be talking about the sine of the value, the ratio, because we're going to deal with the 4 quadrants, and then the second part will be the reference angle. So when I talk about quadrant signs, that means the abscisses and the ordinates can be positive or negative. The x's and the y's can either be positive or negative depending on which quadrant you are in. So depending on whether on which thing is positive and which is negative, that's going to affect your sine, cosine, and tangent ratios. So we will deal with each of the quadrants. The first quadrant, if I have a point on the unit circle in the first quadrant, I know my x value is positive and my y value is positive, so everything's going to be positive. The cosine, the sine, and the tangent, they are all going to be positive. Okay, in the second quadrant, what happens is my x value is negative and my y value is positive. So if you think about our trig functions, remember the cosine of theta is equal to x, the sine of theta is equal to y, so the sine is going to be positive and the cosine will be negative, and that means that the tangent will be negative. So in the second quadrant, the sine is positive. Okay, so the cosine and tangent are negative. All right, if we think about the third quadrant, in there they're both negative, x and y. So that means sine and cosine are negative. But if the sine and cosine are both negative, that means the tangent is positive. And then finally the fourth quadrant, when we are down here, x is positive, y is negative, so that means the cosine is positive, and the sine and the tangent are going to be negative. So in the first quadrant, they're all positive. In the second, the sines are positive. In the third quadrant, the tangent is positive, and in the fourth, the cosine is positive. So we can remember that with A, S, T, C. And the way we typically remember this is to put those initials here, all star trig class, or all students throw cheese, or whatever you want to call it. You can make up any nickname for this that you want, as long as you can remember that which quadrant the trig functions are positive in. One of the biggest mistakes I see in this unit is that you forget sometimes the sine and the cosine and the tangent will be negative when you evaluate functions. So let's see how we use this in an example. I just want to know if we're not going to evaluate it, but if the answer would be positive or negative when you're done. So let's look at the sine of 120. The sine of 120, 120 degrees, that's in the second quadrant. So that's in quadrant number 2. Since it's sine, it's going to be positive. If we look at the cosine of, let's look at 7 pi over 6. 7 pi over 6, if you were to convert that if you needed to, or just think about it, 6 pi over 6 is 180 degrees, so 7 pi over 6 is going to be in the third quadrant. And in the third quadrant, the only thing positive is tangent, therefore this answer would be negative. So other than the quadrant sign, the other thing we're going to look at today are the reference angles around the unit circle, because we need the reference angles to evaluate the exact ratio of the sine, cosine, and tangent using our special angles. So reference angles are referred to with the little bar across the top of the theta symbol, and reference angles are always between 0 and 90 degrees. Because we break this up into two parts. We evaluate the function based on the reference angle, and then we attach the appropriate sign depending on the quadrant of the original angle. So just to look at the reference angles, we have 4 cases for the 4 quadrants. For the first quadrant, all angles are between 0 and 90. So for the first quadrant, the reference angle is equal to the angle itself. Theta bar is going to be equal to theta. For the second quadrant, we now are between 180 and 90, so the reference angle is going to be the angle that you get when you take 180 and you subtract away theta. So in this case, theta bar, the reference angle, is 180 minus theta to get that angle between 0 and 90 degrees. For the third quadrant, your original angle is greater than 180, and we want the difference between the original angle and the 180 degrees to get the reference angle between 0 and 90. So in the third quadrant, theta bar is going to be theta minus 180. And then in the fourth quadrant, we want to take 360 and subtract away the angle so we can get our theta bar, our reference angle. So theta bar is 360 minus theta. Now for all of these, we could also do this in radians. Up here, for the second quadrant, it would be pi minus theta. For the third quadrant, it would be theta minus pi. And for the fourth quadrant, it would be 2 pi minus theta. Any of those, that's what we would use to get our reference angles. So we'll finish this lesson with a couple of examples and then practice more in class. Find the reference angle if theta is 225 degrees. Well, I always recommend you sketch a little graph. 225 is going to be down in the third quadrant. So to find theta bar, you take 225 and you subtract away 180. And you're going to get 45 degrees when you're done. Okay, for example number 2, 9 pi over 4. If you think about where 9 pi over 4 is, or you can convert it to degrees, 9 pi over 4 is going to be, well, 8 pi over 4 is 360 degrees. So this is actually in the first quadrant. So your reference angle is going to be right there. Or you could take 9 pi over 4 and subtract 2 pi from it, and you're going to end up with pi over 4. So that's a brief introduction to quadrant signs and reference angles, and we will practice more of this in class. We'll also create our radian clock in class as well, so we can start evaluating angles around the circle.